January 17, 1940, Tokyo. The snow fell softly over the Imperial Palace grounds, muffling the sounds of the city beyond its ancient walls. Inside a nondescript building adjacent to the Foreign Ministry, beneath electric lamps that cast long shadows across polished wooden floors, a Japanese diplomatic clerk fed a fresh sheet of paper into a machine. The device before him was a masterpiece of electromechanical engineering, a cipher machine the Americans would later call Purple. Its rotors clicked and whirred with mechanical precision as classified text transformed into seemingly impenetrable code. The clerk smiled slightly, satisfied. The message would reach Washington within hours, encoded in a cipher that Japan's finest cryptographic minds had assured the government was absolutely unbreakable. Across the Pacific Ocean, in a cramped office building on the outskirts of Washington, D.C., a different kind of snow was falling. William Friedman, chief cryptanalyst for the U.S. Army's Signal Intelligence Service, sat hunched over sheets of intercepted Japanese diplomatic cables. His eyes were bloodshot from exhaustion, his hands trembling slightly as he arranged columns of seemingly random letters. Around him, a small team of mathematicians and linguists worked in near silence, the only sounds the scratch of pencils on paper and the occasional frustrated sigh. They had been studying these messages for months now, searching for patterns in chaos, looking for the mathematical fingerprints that every cipher, no matter how sophisticated, inevitably left behind. Neither the Japanese clerk nor William Friedman could have known, in that frozen moment of January 1940, that they stood on opposite sides of an invisible war, a war of mathematics and intuition, of arrogance and determination, of secrecy and revelation. A war that would ultimately help decide the fate of the Pacific, though not a single shot would be fired in its prosecution. The story of Purple begins not with technology, with the dangerous intoxication of certainty. Throughout the 1930s, as Japan's military ambitions expanded across Asia, the nation's diplomatic corps operated under an assumption of invulnerability. This confidence was not without foundation. Japan had successfully employed cipher machines for years, evolving their cryptographic systems with each generation. The machine that preceded Purple, which American cryptanalysts had designated Red, had served Japanese diplomacy well through the mid-1930s. When Japanese cryptographers introduced Purple in February 1939, they believed they had achieved something approaching cryptographic perfection. The Purple machine represented a quantum leap in cipher technology. Unlike its predecessor, which used mechanical rotors similar to German Enigma machines, Purple employed telephone stepping switches, components originally designed for automated telephone exchanges. This innovation created encryption patterns of staggering complexity. A single message could be enciphered through billions of possible combinations. Japanese cryptographers calculated that even with unlimited resources, breaking Purple through brute force would require decades of continuous effort. The mathematics seemed irrefutable. The conclusion appeared inevitable: Purple was unbreakable. This conviction permeated every level of Japan's diplomatic and military hierarchy. Ambassador Kichisaburo Nomura used Purple encrypted cables to communicate Japan's most sensitive diplomatic positions to Washington. Foreign Minister Yosuke Matsuoka relied on Purple to coordinate with Japanese embassies across the globe. Even as tensions with the United States escalated through 1940 and 1941, even as war clouds gathered over the Pacific, Japanese officials never seriously questioned whether American intelligence might be reading their most secret communications. The possibility seemed too remote to warrant concern. But this certainty contained within it a fatal assumption, that American cryptanalysts would approach Purple the way Japanese engineers had designed it, as a mechanical problem requiring mechanical solutions. What Japanese intelligence officers failed to anticipate was that American codebreakers would approach Purple not as engineers, but as pure mathematicians, abstracting the machine into patterns of probability and statistical distribution. William Friedman came to cryptanalysis through an unusual path. Born in Russia, educated in genetics at Cornell University, he had initially worked as a geneticist at a research facility dedicated to proving that Francis Bacon had written Shakespeare's plays through hidden ciphers. Though that particular theory proved unfounded, the work introduced Friedman to the mathematical beauty of ciphers and codes. By 1930, he had become the U.S. Army's chief cryptanalyst, assembling around him a small team of brilliant minds, mathematicians who could see patterns where others saw only chaos, linguists who understood that language itself possessed predictable structures that even the most sophisticated cipher could not entirely eliminate. When Purple first appeared in Japanese diplomatic traffic in early 1939, Friedman's team recognized immediately that they were confronting something unprecedented. The messages showed none of the statistical patterns that had allowed them to break red. Standard frequency analysis, the bedrock technique of cryptanalysis since medieval times, yielded nothing. The distribution of letters appeared genuinely random. For months, Friedman and his team worked in near-total darkness, gathering intercepted messages, searching for the slightest asymmetry that might provide a foothold for deeper analysis. The work was methodical, exhausting, and often demoralizing. Each day brought new intercepts, and each intercept seemed to confirm Purple's impenetrability. Friedman's team worked 12-hour shifts, then 14-hour shifts, fueled by coffee and determination. They filled notebooks with letter frequencies, positional analyses, tests for periodicity. They explored every theoretical vulnerability they could imagine. And still, Purple remained opaque. What sustained them through these months of apparent futility was a fundamental article of faith among cryptanalysts, that no cipher created by human minds is truly unbreakable. Every encryption system contains within it certain inherent limitations imposed by the need to decrypt messages efficiently at the receiving end, limitations imposed by the structure of language itself. The challenge was not whether Purple could be broken, but whether Friedman's team could find the path to breaking it before time, resources, or national interest ran out. The breakthrough, when it finally came, emerged not from a single flash of insight but from the gradual accumulation of small discoveries. Frank Rowlett, one of Friedman's most gifted mathematicians, noticed that certain Japanese diplomatic messages showed patterns in the placement of vowels and consonants. The pattern was subtle, almost invisible, but it was there. This suggested that Purple, despite its complexity, maintained some distinction between how it processed different types of letters, that it was not, in fact, a completely uniform cipher. Building on this observation, the team hypothesized that Purple might divide the alphabet into separate groups, processing each group through different cryptographic pathways. If true, this would mean that instead of confronting one incomprehensibly complex cipher, they were actually dealing with multiple simpler ciphers operating in parallel. The hypothesis was testable. For weeks, Friedman's team analyzed intercepts under this assumption, gradually mapping out which letters belonged to which groups, how the groups interacted, what patterns governed their transformations. By September 1940, 18 months after Purple's introduction, the American cryptanalysts had achieved what Japanese intelligence officers had declared impossible. They had reconstructed Purple's logical structure without ever having seen the actual machine. Working from pure analysis of encrypted text, they had determined that Purple divided the alphabet into two groups, 6 letters processed through one pathway, 20 letters through another. They had discovered that the machine's stepping switches advanced through predictable patterns, creating a kind of mathematical rhythm beneath the apparent randomness. And most remarkably, they had built a functioning Purple analog, a machine of their own design, using telephone equipment purchased from American suppliers, that could decrypt Japanese diplomatic messages as efficiently as the original Purple machines in Tokyo. On September 25, 1940, Friedman's team successfully decrypted their first complete Purple intercept without external assistance. The message was a routine diplomatic communication, unremarkable in content, but its significance was cosmic. The supposedly unbreakable cipher had been broken. The invisible had been made visible. Yet even as American cryptanalysts celebrated this triumph, the Japanese officers whose communications they could now read remained blissfully unaware of the catastrophe that had befallen their cryptographic security. This ignorance stemmed partly from operational security on the American side. The intelligence derived from Purple decrypts, codenamed Magic by U.S. officials, was handled with extraordinary care. only the highest-level military and political leaders received magic material, and even they saw only sanitized summaries that concealed the source of the information. Elaborate deception schemes ensured that when the United States acted on purple-derived intelligence, the action appeared to result from conventional espionage, signals analysis, or simple luck. Never could the Japanese be allowed to suspect that their supposedly unbreakable cipher had been compromised. But Japanese blindness to Purple's vulnerability also reflected deeper institutional failures. Failures of imagination, of humility, of willingness to question fundamental assumptions. Throughout 1940 and 1941, as American cryptanalysts read virtually every significant Japanese diplomatic communication, Japanese intelligence officers received scattered hints that their codes might be compromised. Japanese diplomats occasionally noticed that American negotiators seemed unusually well informed about Japanese bargaining positions. Foreign intelligence services occasionally provided warnings that American code-breaking capabilities might be more advanced than assumed. Yet these warnings were consistently dismissed or explained away. Purple's mathematical sophistication seemed to guarantee its security. The idea that Americans could have broken it without access to an actual machine seemed not just unlikely but impossible. This dismissal was not simply a matter of technical overconfidence. It was rooted in a broader Japanese underestimation of American capabilities, an underestimation that would prove catastrophic as the Pacific War unfolded. Many Japanese military and political leaders had spent the 1930s convincing themselves that the United States lacked the discipline, the intelligence, and the cultural cohesion to stand against Japanese expansion. Americans were seen as decadent, distracted by internal divisions, incapable of the collective sacrifice necessary for total war. This prejudice extended even to assessments of American technical and scientific capabilities. How could a nation of individualists and materialists match the focused determination of the Japanese Empire? What Japanese officers failed to appreciate was that American individualism, far from being a weakness, was a profound strategic asset in fields like cryptanalysis. The American cryptographic effort was not a massive, centrally directed project but a relatively small team of exceptional individuals, working with minimal bureaucratic interference. Friedman and his colleagues were not following rigid doctrines handed down from above. They were improvising, experimenting, following their intellectual instincts wherever those instincts led. They represented the very best of a system that rewarded individual initiative and creative problem-solving. Moreover, the United States possessed a depth of technical and industrial resources that Japan could not match. When Friedman's team needed specialized equipment, American industry could provide it. When they needed additional personnel with specific mathematical skills, American universities could supply them. The Purple analog machines that American cryptanalysts built required sophisticated telephone switching equipment that the United States manufactured in abundance but that would have been difficult for Japan to produce in equivalent quantities. So through 1940 and into 1941, while Japanese diplomats encrypted their messages with confidence and American cryptanalysts decrypted those same messages with growing efficiency, the gap between perception and reality widened into a chasm. The strategic consequences of this cryptographic blindness became apparent with terrible clarity in the months leading to Pearl Harbor. By mid-1941, United States intelligence was reading virtually all high-level Japanese diplomatic communications in real time. When Japanese Foreign Minister Matsuoka cabled his ambassadors in Berlin and Rome about Japan's intentions regarding the Soviet Union, American officials read those cables. When Ambassador Nomura received instructions on Japan's maximum negotiating positions in ongoing talks with Secretary of State Cordell Hull, American negotiators knew Japan's bottom line before Nomura opened his mouth. When Tokyo informed its diplomatic missions to begin destroying code books and cipher machines, the traditional preparation for war, American intelligence knew within hours. Most critically, on December 6, 1941, Purple Intercepts revealed that Tokyo had ordered its Washington embassy to deliver a message to the U.S. government at precisely 1 p.m. Eastern Time the following day, a message that would effectively sever diplomatic relations. American intelligence officers, reading the Intercepts, understood immediately what 1 p.m. Washington time meant, 7:30 a.m. in Hawaii. The timing was not coincidental. Something was going to happen in the Pacific at dawn on December 7th. The intelligence was there. The warning was clear. Yet due to a combination of bureaucratic dysfunction, communications failures, and simple disbelief that Japan would actually attack the United States directly, that warning never reached the commanders at Pearl Harbor in time to prevent catastrophe. When Japanese aircraft appeared over Oahu that Sunday morning, they achieved complete tactical surprise. But if the attack itself surprised American forces in Hawaii, Japan's strategic intentions had been an open book to American intelligence for months. In the aftermath of Pearl Harbor, as the United States mobilized for total war, American military planners operated with an intelligence advantage that Japan's leaders could not begin to comprehend. Every major Japanese diplomatic initiative, every strategic debate in Tokyo, every instruction sent to Japanese commanders in the field, all of it filtered through purple encryption, and all of it arrived on American desks in readable form. The advantage was not absolute. Purple encrypted diplomatic traffic, not military communications. Japanese naval and army units used different cipher systems, and these proved more difficult to break comprehensively. But diplomatic intelligence provided crucial context for understanding Japanese strategic thinking. When Japan's ambassador to Berlin reported on conversations with German officials about coordinated Axis strategy, American planners gained insight into Japanese-German relations. When Tokyo sent instructions to its diplomats in Vichy, France regarding bases in Indochina, American intelligence learned of Japanese movements before those movements began. Perhaps most valuable were the insights Purple provided into Japanese assessment of their own strategic situation. Through intercepted diplomatic messages, American intelligence could track how Japanese officials evaluated the progress of the war, what resources they believed they had available, what their priorities were, where they saw vulnerabilities. This intelligence could not predict every tactical decision, but it provided a strategic roadmap of Japanese thinking that proved invaluable for American war planning. And through it all, Japanese officials continued encrypting their messages with Purple, continued expressing their most sensitive strategic assessments in a cipher they believed was unbreakable, continued operating in blissful ignorance of the American eyes reading every word. The Purple story represents one of the great ironies of the Pacific War, that Japanese confidence in technological superiority contained the seeds of strategic vulnerability. Japanese cryptographers had built a genuinely sophisticated cipher machine. Purple was not a flawed system that competent analysis would quickly penetrate. Its breaking required 18 months of intensive effort by some of the finest mathematical minds in America, working with limited resources and no direct access to the machine itself. In a different context, with different adversaries, Purple might well have served Japan faithfully throughout the war. But Japan's leaders mistook difficulty for impossibility. They confused the improbability of breaking Purple through brute force with the impossibility of breaking it through mathematical insight. And this confusion led them to ignore warning signs, to dismiss contrary evidence, to persist in using a compromised cipher system even as their strategic position deteriorated. The contrast with American approach to cryptography is instructive. American military communications used multiple cipher systems, regularly updated and replaced. When American cryptanalysts suspected a cipher might be compromised, they changed systems, sometimes on the basis of fragmentary evidence or theoretical vulnerabilities that had not yet been exploited. The approach was cautious, paranoid even, but it reflected a fundamental humility about the limits of cryptographic security. No cipher was assumed to be unbreakable. Every system was treated as potentially vulnerable. Japanese cryptographers, by contrast, fell victim to a form of technological hubris. Having created what they believed was the perfect cipher, they could not imagine that anyone else might approach the problem from a perspective they had not anticipated. Their certainty became their blindness. This pattern, of technological confidence breeding strategic vulnerability, appeared repeatedly throughout the Pacific War. Japanese aircraft designers, convinced of the superiority of their Zero fighter's maneuverability, made the aircraft almost unarmored, leaving it vulnerable to American fighters that sacrificed agility for firepower and protection. Japanese naval planners, confident in the superiority of their naval aviation, failed to develop adequate anti-aircraft defenses, leaving their fleet vulnerable to American carrier strikes. Japanese military strategists, convinced of their soldiers' superior fighting spirit, consistently underestimated the effectiveness of American material advantages in production and logistics. In each case, the pattern was the same. Initial Japanese advantages transformed into lasting vulnerabilities because Japanese leaders could not conceive that their advantages might be temporary or that their adversaries might develop effective counters. Pride became rigidity. Confidence became blindness. By 1945, as Japan's strategic situation grew desperate, the Purple Cipher remained in use, still encrypting diplomatic communications between Tokyo and its remaining diplomatic missions, still believed by its users to be secure, still being read by American cryptanalysts with the same efficiency they had achieved in September 1940. In the war's final months, Purple Intercepts provided American intelligence with detailed knowledge of Japanese peace feelers, of internal debates in Tokyo about surrender terms, of the precise conditions under which Japan's military leaders might accept defeat. This intelligence informed American decisions about the use of atomic weapons, about the timing of Soviet entry into the Pacific War, about the terms ultimately offered to Japan in the Potsdam Declaration. Even at the moment of surrender, Japanese officials encrypting their final diplomatic messages never knew that the cipher they had trusted throughout the war had been compromised from the beginning. The revelation came only after the war, when American occupation authorities disclosed the full extent of Allied signals intelligence operations. The disclosure shocked Japanese officials who had spent years operating under the assumption of cryptographic security. The entire war, they realized, had been conducted under American eyes. Every diplomatic stratagem, every negotiating position, every internal assessment had been visible to their adversary from the outset. The psychological impact of this revelation was profound. It forced a reckoning with the broader failures of imagination and institutional culture that had characterized Japan's approach to the war. The same arrogance that had dismissed American industrial capacity, that had underestimated American willingness to accept casualties, that had failed to anticipate American strategic adaptability, that same arrogance had blinded Japanese intelligence services to the vulnerability of their own communications security. There is a peculiar poetry in the Purple story, in the image of messages traveling across the Pacific encoded in a cipher that both sides could read, one side confident in its security, the other quietly exploiting its transparency. It speaks to the fundamental asymmetry of knowledge in warfare, the way battles can be won or lost in the shadows before the first shot is fired. But the deeper truth the Purple story reveals is about the danger of certainty itself. Japanese cryptographers built a sophisticated system and declared it unbreakable. American cryptanalysts approached that same system with humility, with the working assumption that every code contains vulnerabilities, with the patience to search for patterns over months and years until those vulnerabilities revealed themselves. In that contrast between arrogance and humility, between certainty and skepticism, between closed minds and open questions, lies a lesson that extends far beyond cryptography or even warfare. Certainty is seductive. It is comfortable. It eliminates doubt and provides clear answers in an uncertain world. But certainty also blinds. It prevents us from seeing what contradicts our assumptions. It makes us vulnerable precisely at the points where we believe ourselves most secure. The Japanese officers who continued using purple throughout the war, who never questioned whether American intelligence might be reading their messages, who dismissed warnings and ignored anomalies because they contradicted their fundamental assumptions, these officers were not stupid or incompetent. They were intelligent, dedicated professionals operating within a system that valued certainty over skepticism, that rewarded confidence over doubt, that could not accommodate the possibility that American cryptanalysts might achieve what Japanese cryptographers had declared impossible. And so the messages continued flowing across the Pacific, encrypted and decrypted, read by both sender and recipient, and silent observers in between, until the war ended and the silence finally broke and the truth emerged from the shadows into the light of historical record. In Washington, D.C., in a secure facility that no longer exists, preserved in the archives of American signals intelligence, there remain thousands of decrypted purple messages, diplomatic cables containing the inner thoughts of an empire at war, preserved perfectly, like insects in amber, frozen at the moment they were intercepted and decoded. They speak now not just to the strategic situation of 1941 or 1942 or 1945, but to something more fundamental about the nature of knowledge and certainty, about the dangers of assuming that what we believe to be impossible actually is impossible, about the way wars are won not just through material superiority but through superior understanding of reality itself. The clicking of cipher machines has long since fallen silent. William Friedman died in 1969, his contributions to American intelligence finally acknowledged after decades of secrecy. The Japanese diplomats and cryptographers who trusted Purple have passed into history. But the lesson remains, carved into the historical record with the clarity of mathematical proof, that certainty, however comforting, however seemingly justified by technical sophistication or theoretical analysis, is no substitute for constant vigilance, for willingness to question assumptions, for the humility to recognize that what seems impossible today may become routine tomorrow. In the end, that may be the most enduring legacy of the Purple Cipher, not the specific intelligence it provided during the war, but the broader truth it illuminated about the relationship between knowledge and power, between certainty and vulnerability, between the assumptions we make about our own security and the reality that those assumptions may be nothing more than comfortable illusions, waiting to be shattered by adversaries who refuse to accept the limits we imagine to be absolute. The snow that fell over Tokyo on that January morning in 1940 has. Cipher machine that seemed unbreakable was broken. The certainty that appeared absolute proved illusory. And somewhere in the mathematical distance between what Japanese officers believed and what American cryptanalysts proved, in the silence between encrypted message and decrypted intelligence, lies a truth as relevant today as it was then, that in warfare as in cryptography, the most dangerous vulnerability is not the one you have failed to protect, but the one you are certain does not exist. Claude can make mistakes. Please double-check responses.